Hi everybody, Nick Plaisir back here with another position analysis video. Today's is going to be a little bit more like a lesson on cube fundamentals and how we approach that by starting at the end of the game when cube decisions are the simplest. But before we hop right into that, I wanted to remind you all of the upcoming commentary I'm going to be doing. So probably some of these tournaments might be done by the time this comes out, but these are the ones on my list right now. I'm doing remote commentary at most of them, but I'll be on site in San Antonio and Virginia. Yeah, I thought I was traveling to London, but I figured out I think I'm going to go there in August and I'm going to do remote this first time around. So definitely check those out. Go to their YouTube channels to figure it out. I'll be posting links on my Facebook page too, of course. And yeah, also just a reminder that my book's out there, of course, but I teach lessons too. So if you want to learn about backgammon or get started with it, reach out to me, or want to dive into some deep topics, I'm happy to help out. I've got information about that on my website too. So yeah, without further ado, we have a classic position that's kind of a nice reference for checker distribution and also for cube action. But I think, if we're brand new to the game, when we're trying to understand the doubling cube and when we should send it, our first instinct is probably that we should send the cube when we're ahead, when we're winning, right? Why not double the stakes when we're winning? And we can see in this position, where this position particularly is a last roll position, so the cube action is going to be a lot easier. So yeah, we can see either we're going to get off both our checkers on this roll and then our opponents, and we're going to win. But if we don't take both checkers off, which happens with a lot of the rolls, then our opponent's going to win because every roll is going to take these two checkers off. So if you happen to know this reference of checkers on the 5 and the deuce, then you recognize that just one roll more than half the rolls takes two checkers off. That's 19 out of 36. And that makes for 53-ish% winning chances for white here, and a slight advantage, which means we can double and gain a little bit of value by doing that. But perhaps what's not like incredibly intuitive, if you're just starting with the game, is why this is still a take for black if they're losing. And I mean, this is just like simple mathematics. We're going to get a little mathy on this just to kind of show it too. But it's not about whether or not you're winning or losing. It's that your other alternative is to pass the cube and lose 1 point. And so how do you figure out if in the long run you're going to lose less than 1 point on average? And in this position, maybe it's fairly clear, but we can show a little bit of math too. I'll pull up like Notepad over here. So with the winning chances you saw, white is going to get off and win 2 points about 53% of the time, 0.53. And so on average, when they win, they're getting plus 1.056 points for that portion of what can occur. We're just taking the chances of winning 2 points and multiplying that. And then we can add that or subtract from it the chances of white missing and black winning 2 points. And that's going to be 0.944. And so if we compare those two, okay, I got to go over here and click. Then what we end up with, if we subtract them out, is minus 0.112 points. And again, we're comparing this to the other option of just losing 1 full point. And so you can see that we lose almost 9/10 of a point less by playing this position out. So yeah, in the math of backgammon works this way. It's kind of similar to like poker odds and things like that, if you're familiar with pot odds and when you should put money in the pot as an underdog because you're going to get paid back so much more. We have a similar like situation where there's already a point in the center in a sense, and we can think about it that way. And so another nice example to go along with this is just another reference, is that if we have checkers on the 4 and the 3 instead of the 5 and the 2, well, now 17 out of the 36 rolls get off, and the other 19 do not. And so white should not double here because they're an underdog, of course. But then what starts to happen when there's potentially more rolls? So if we're still a favorite, from the center, we'll kind of show how cubes get involved. But well, let's think about it this way. We'll show another one about the take-pass borderline here real quick. So in this position, a full 3/4 of the rolls are going to take white's checker off and win the game. and the rest of the time black's going to win. And this is a good reference for exactly the take pass borderline, and we call that the take point. And so the reason for this, you can see 3/4 of the time white wins, 1/4 of the time black wins. So black is perfectly indifferent. Either way, in the long run, they're going to lose a point by playing this cube. And so we can look at the math of that the same way and just like compare now if 3/4 of the time we're going to win 2 points when our opponent accepts the game for 1.5 points total. And then 1/4 of the time we're going to lose 2 points. So we subtract 0.5 from 1.5 and we find out that our equity in the position is -1, which is the same as if we passed every time. And so this is a key number for understanding how last roll cubes work. But things get a little bit fuzzier if there are more rolls in the game and the cube might get involved. And so we already looked at this position here where we're going to get Notepad out of the way there too, where we win slightly more than half the time, so we send the cube. And we would think too, so if the cube is in the center, of course, and we make this a little worse, well, we're going to win more often, right? And we can see in this position that certainly we do. The value is a little bit higher, but we're still way above that 25% is black. So still a simple take. But we have a fun little like cube dynamics thing with this, and it's complicated math to get into it, but I feel like showing it. The Jacoby Paradox, if you haven't seen it. What if we own the cube? Well, now the game's a lot more complicated because a couple things are happening in this position. What's going to happen is if we don't get both checkers off, let's go through this real quick. Let's imagine the centered cube. It's not as simple as just the wins and like calculating out like we did last time, because there's more cube action that can happen. If we send the cube here, we're not doing as well as you can see. The equity is not like a ton higher than when we had 52%, not like 13% winning chances higher. But so when we say we roll a 2-1, or we'll say a 3-1 for fun, and white has to play their checker to the ace point. Well, now after we've sent the cube, black has a cube action here, and it's going to be 10 rolls that aren't going to take black off the board, and the rest of the time white's going to win. So we're like a little better than the reference, the 75-25, and so white's going to have a clear take. But what that means is that instead of just winning 2 points, instead of the math being as simple as white wins 2 points whenever they take two checkers off and they lose 2 points the other times, well, now we have to do some complicated math to figure out exactly what the equity is, because white's going to win 2 points every time they take two checkers off. Then they're going to take, and there's going to be take a 4 cube back, right? And we're going to be dealing with how often, or like how many points black wins when they take their two checkers off and how many they lose when they don't, right? And so this makes for an interesting position if we own the cube before the roll instead. And we saw with the centered cube, just as a reminder once more, that it is a double from the center because we both have access to the cube. But when we own the cube, we can prevent our opponent from sending the cube in this pretty good position when we miss. So we'll get a little better than a quarter of the time. We'll just get to try to let them miss and win our 2 points anyway. Where if we send this cube, then our opponent's going to be able to send it back, and we're going to lose a lot of the time on 8 when things go poorly. And so in this particular position, we can see XG actually tells us that the equity is better to not send the cube, even though we're a pretty sizable favorite in the equity here. So how can that be? So we can run through the math just to show it. But we have to go through, and backgammon gets really complicated this way very quickly when there's game to go and cubes might get back in. And so this is like the real dilemma with sending the cube. It's rarely as simple as the last roll position. But we'll just show, because this one, is solvable with math. We'll go through it real quick for fun. But it's complicated, and you'll see from going through this too, that very clearly is going to be difficult, if not impossible, to calculate this in most regular backgammon positions. And this is why we're using references and rules of thumb and trying to figure it out that way. But, so in this one, in the Jacoby Paradox position, we can see that, yeah, sorry. I was also showing in that quarter, we'll just skip past that. Maybe a simpler way to think about, instead of like calculating the equity in the, let's look at this position real quick. But on the board here, when we think about the position where we win 3/4 of the time and we send the cube, maybe an easier way to think about this is to pretend like we just play all 4 games as average. And 3 of the times, black is going to lose 2 points when they accept the cube. And 1 of the times they're going to win 2 points for a net of -4. Or in all 4 games, they could just pass, 1 point for a total of -4 as well. And so we can get that way that it's a nice, like, perfectly break even and same decision either way. But so back to the Jacoby Paradox. Let's get that on the board. And we'll look at the math of this one now. So we already know what the odds, we'll calculate out what our equity is after doubling. And as I mentioned, well, I guess I didn't explain exactly what that equity is, but that's what the calculations that we're doing. We're talking about our equity when we multiply our winning chances times the amount of points we're going to make, and on average, how many points we're going to earn in each game. And that's what the numbers in XG correspond to. But so in this scenario now, if we're holding a 2 cube and we send a 4 cube, well, now 0.5278 times, every time we take 2 checkers off, we're going to win 4 for a total of 2.1 points, right, that we're going to earn there. But when we miss, we have a little bit more complicated scenario to calculate out, right? What's going to happen there is 0.72, 72% of the time, our opponent, well, first they're going to recube, and we're going to be playing on 8, right? And then 72% of the time, they're going to win 8 points from us. So we're going to lose -8. So that's worth -5.76 points in equity right there. But the other 28% of the time, we're going to win 8, and we're going to get 2.24 points of that back. And so after that happens, whenever we miss, that's a full -3.52 points that we're going to lose on average. So we can multiply that by the odds of that happening and show that in that scenario, we're going to average out -1.66 points. And so now all we have left to do is to compare the number of points we win when we take 2 checkers off to the number of points, the equity, when we don't. And we get a total equity of 0.45 points. So we're still positive when we cube in this scenario, which can be confusing as well, right? We're still doing good, but potentially there's a way to do better. And we can see here too in the numbers on XG that we do have positive equity when we redouble. And the reason we're seeing something a little bit different here is because it's like normalized to the 2 cube and everything like that. So we're doing this in terms of like a 4 cube, and it comes out a little bit closer, but and we're rounding some, so don't worry about why that's different. But yeah, why it's different than what we have in the notepad. But you can see again, what I want to point out is that redouble take number, the plus 0.216, is still positive equity when we redouble. But on the right, it's showing us that it's minus 0.102 compared to not redoubling. And so let's calculate out the path when we don't redouble. It's a little simpler. In that case, about 53% of the time, we're going to win 2 points, just the simple 2 cube for 1.06. On the other side of the coin, the 47% of the time, well, then we once again have 72% of the time we're losing 2 for minus 1.44. 28% of the time we're winning 2 for 0.56. And so when you sum those together, we get minus 0.88 that we're losing whenever we miss on average. And when we multiply that out, that's another minus 0.42 points of equity. And so now when we compare the smaller 1.06 that we win on the 2 cube and subtract the 0.42, we end up with 0.64 equity total. And so we can see that on average, when we don't double, we're going to win 0.64 points. And when we do double, we're winning 0.45 points. And so not doubling is higher, right? And if we look back at that again, I mentioned that the numbers are a little bit different. What it has a lot to do with is that XG is also normalizing this number on this 2 cube. Instead of calculating the points as though we're going to win 2 or 4 or 8, it's going to reduce this to 1 and just kind of if everything was equal. So the numbers look a little bit different. But so we can see the math's possible, but it's like the point of this is that it's possible to get into positions where, because of how your opponent's going to be able to leverage the cube, they will do better even though they're losing if you give them the cube as a weapon, and it might be better to just hold it. So there's like a waiting game until the last point that they can like take it, and making sure you're maximizing your equity that way too. So the math is a little complicated, but hopefully it gives you an idea of how the cube works mathematically. And if you have that in mind, you have a better feel for what you're trying to do with it. And we're going to get to references and things like that in general. But yeah, this is an interesting one, and it's fun to go through the math. It's fun to kind of go through all this and calculate it on your own too if you have a different way of doing this. But yeah, I hope that helps with some fundamentals of how cube action works in backgammon. And I'll be back with more position analysis videos soon. Thanks, everybody.